Now let's take a look at this figure 7-4 dealing with a Y-connected type transformer. Now in the illustration at the very top of the transformer, we have a call out there, transformer Y-connected, 3-phase 3-wire. So what I'm pointing out, we're eliminating the neutral because we're going to take the phase-to-phase voltage and use the 58% rule to determine the winding voltage. Now you could find it in a quick calc by taking 208 volt, divide by the square root of 3, 1.732, and you get 120. Or you could take 208 volt times 58%, come up with 120. Now, the 58% rule is applied in finding the winding voltage. In the step 1, we take the phase-to-phase voltage, 208 volt, times 58%, we come up with 120. So in the solution, the winding voltage is 120 volt based upon 58% of the phase-to-phase voltage. Now, when we look at 430.7b22, we'll find that we can start a motor on a Y connection and run it on a delta. Now, we're going to go through this in more detail as we go through these videos on transformer, basic theory. But this figure 7-4 is illustrating a Y-connected transformer, 208 volt phase to phase, applying the 58% rule to come up with 120 volt winding voltage. And that's what our figure 7-4 is illustrating to the user of the NEC installing transformers, and again based upon theory.